In 2012, Zhongcheng Yu left his job as an engineer at a company called ASML, the only company in the world that can make this machine. This machine makes the most advanced semiconductor chips, or microchips, in the world. After he left ASML, he started two new companies, one in the US and one in China. US and ASML lawyers would later allege that Yu recruited other ASML engineers to his US company, that they brought with them stolen information about ASML's machine, and that it was all backed by the Chinese government. This story is just one small piece of China's monumental effort to transform one of the world's most global and significant industries, semiconductors. But China's effort has increasingly locked it in a struggle with the United States.
This isn't about market share, this isn't about tariffs, this is about security.
So how exactly did China and the US enter into a Cold War over computer chips? This is the first semiconductor chip, invented in the 1950s by engineers in the US. It's a piece of silicon with 4 transistors on it. The more transistors, the more powerful the chip. By 1960, engineers had already made one with 4 times the transistors, and each year they figured out ways to add more.
So since the early 1960s, semiconductors have improved at an exponential rate.
This is Chris Miller, author of Chip War.
The founder of Intel, Gordon Moore, predicted in 1965 that the computing power produced by a single chip would double every year or so, and that rate has held true roughly up to the present.
The first companies dedicated to making chips were in the US, where they really just had one main customer, the US government.
The first use cases were actually in guidance computers that were in NASA spacecraft as well as in missile system.
The complex guidance equipment, the system's electronic brain.
Since chip companies were making better and better chips each year, the US government believed a deep partnership with them would ensure that it always had access to the most advanced ones.
The US government has believed that computing has been a core determinant of nations' power on the world stage. You think about the ways that computing has been used to crack codes in World War II or to track Soviet submarines during the Cold War. I think that judgment is correct.
At first, these chip companies handled the entire supply chain. They designed the chips, manufactured them, and assembled them into a package for installation into a product, all within the US. But by the late 1960s, they realized they could make a lot more money designing chips for civilian products, like corporate computers. They just had to make a lot more of them, and a lot less expensively. So many chip companies moved their manufacturing and assembly to factories in Japan, Taiwan, South Korea, and Hong Kong, where labor was cheaper, and the US government encouraged them. All these countries were US allies or partners, and this was a way to support their economies and deepen ties. At the same time, it banned these chip companies from sharing technology with its rivals, the Soviet Union and China. It was a way to keep them years behind the US as chips advanced.
Because of Moore's law, advanced chips are substantially better than previous generations. If you're 5 years behind or 10 years behind, you're actually quite far behind the cutting edge.
But it wasn't long before these allied governments began investing in their own chip companies. In the 1970s and 80s, Toshiba in Japan and Samsung in South Korea began designing and manufacturing chips that rivaled the Americans. And in the 1990s, a Taiwanese company, TSMC, got so good at manufacturing chips that many companies in the US stopped doing it. It meant that US companies were not the only ones who could make the most advanced chips anymore. And every country's chip industry was increasingly reliant on other countries for the materials, software, and equipment needed to make more complex chips. But while the US and its allies were pushing the limits of chip technology, China was lagging behind. In addition to the US blocking it from accessing chips during the Cold War, many of China's brightest scientists and engineers had been driven out of the country by the dictator Mao Zedong during the 60s and 70s. But over the next few decades, new Chinese leaders pushed to catch up. By the 1990s, the Cold War was over. The US had become friendlier with China, and it had lifted most of its export controls. And so China enticed many chip companies to move their assembly operations to China. And by the 2000s, China dominated this end of the supply chain. But China was importing more and more chips to feed its assembly industry, and it put them in a tricky position.
The Chinese government had studied the tech supply chain, and they realized the entire Chinese tech ecosystem relied on a foundation of imported silicon from China's geopolitical adversaries, from the United States, from Japan, from Taiwan, and China's leaders concluded, quite understandably, that this was a risk they were unwilling to continue to take.
So the Chinese government poured money into its own chip design and manufacturing companies. which increasingly partnered with non-Chinese firms, all in the hopes of creating a chip supply chain that existed entirely within China. Soon, China could design, manufacture, and assemble some older generations of chips mostly on its own, but it was still years away from making the most cutting-edge chips. This is one of those chips. It's got around 114 billion transistors on it. Remember, in 1960, chips had 4.
Computing capabilities of the future, just like the computing capabilities of the past, will be deployed to military uses.
The problem is only a few companies in the world are involved in making them, and none are in China. To start, only 3 American companies make the software needed to design advanced chips. Then, turning those designs into real chips requires a machine that's only made by one company, ASML. But this machine requires equipment that's only made in the US. Finally, only companies in Taiwan and South Korea can put it all together and manufacture the most advanced processor chips. These companies are choke points in the supply chain, and China was totally reliant on them for advanced chips. In 2019, police in the US went to arrest Zhong Chengyu, but couldn't find him, until he appeared later in China as the CEO of his company that successfully made software like ASML's. Thanks to help from the Chinese government, his company was flourishing. And his story was just one of several instances of IP theft in the chip industry.
The Chinese government has been, at the very least, passively supportive, but in some cases actively supportive of IP theft, because the Chinese government realizes that its companies are in a position of relative weakness.
In order to eventually decrease its reliance on this foreign supply chain, China was identifying choke points like ASML and copying them. But the plan backfired.
And this has really angered US government and other governments, and caused them to take China's subsidies as a more security-focused issue rather than just an economic issue.
This was happening at the same time that the relationship between the US and China was becoming less cordial and more competitive.
China's market distortions and the way they deal cannot be tolerated.
A tremendous intellectual property theft situation.
Game on here, a trade war between the United States and China.
Trump says he plans to impose a 10% tariff increase on China.
If they don't want to trade with us anymore, that would be fine with me.
In 2018, the Trump administration banned US companies from selling components to ZTE, a Chinese tech company. Then in 2019, it banned US companies from doing business with China's biggest tech company, Huawei, and its affiliates. These bans nearly bankrupted ZTE and dealt a significant blow to Huawei. In 2022, the next US president, Joe Biden, targeted China's chip industry more broadly. First, it banned all US companies from selling advanced chips to China, but it also blocked Chinese design companies from using US-made design software and US-made manufacturing equipment. Plus, it banned global companies who use US semiconductor technology from selling advanced chips to China as well. The US was exploiting these choke points to stop China's chip industry in its tracks.
These export controls represented a really clear shift away from the view that ultimately trade and tech exchanges with China were fundamentally positive-sum to a much more zero-sum view of the technological competition.
Next, the US passed a law that would invest billions of dollars into its own chip manufacturing companies, and finalized a deal with Taiwan's biggest manufacturer, TSMC, to build manufacturing plants in the US, all to enable the US to keep racing ahead.
China and the US have a pretty similar view of the political stakes when it comes to semiconductors. That's why the US government has made it a priority to defend the US lead.
But this has also put extraordinary pressure on another conflict between the two countries. Since 1949, China has viewed Taiwan as a breakaway province and has vowed to reunite with it, even threatening invasion. The US has vowed to protect Taiwan, but Taiwan also happens to own the most important choke point in the chip supply chain. Taiwanese companies manufacture 63% of all chips and about 92% of all advanced chips. With companies that are indispensable to both the US and Chinese chip industries, Taiwan has built itself some protection. But the US export controls forced Taiwan's companies to make a choice: defy the US and keep selling to China, or comply and cut off China from some of its chips. So far, they've signaled they'll cut off China. But as China and the US feud over chips, more and more choices like these are going to be imposed on countries and companies around the world, asking them to pick sides in what looks a lot like a new Cold War.